Question 9. The diagram shows the positions of 3 points A, B and C on a map. It says the bearing of B from A is 70 degrees. So that's the first thing we should look at. Now, one thing that I always do with bearings is to draw the north lines and extend them a little bit. And then you can make some nice parallel lines. When I say parallel, I'm saying this is parallel to this one is parallel to this one. So the bearing of B from A is 70 degrees. So we always turn clockwise. So we want to go from A, which is here, and we want to turn 70 degrees clockwise. And then we're on this line here, which takes us to B. So we can mark that angle in there, 70. Now the important thing about this diagram is it says AB is the same as CB. So triangle ABC is isosceles. Now we already have 50 degrees, which means these two base angles must make 130 together, so they're 65 each. So we can now work out the bearing of C from A. So here's A again. We'll turn clockwise, and there we go. We've turned through 135 degrees, and then we're on track to go towards C. So the bearing is 135 degrees. Question 10. The graph shows the depth d centimetres of water in a tank after t seconds. And the first thing it says is find the gradient of this graph. Well, the gradient is a nice way of saying how steep that line would be. Now we know it goes downhill, so it's going to have a negative sign. And if we start from somewhere that we know, say here, which is at 20, and we go along a certain distance, so let's go along this much here, and that would be 10, 20, 30, 40 units here of time. Then we're going down by, well, 180 to 120, that's 60. Now the way I look at the gradient, the easiest way to find that is to go along 1 unit on the x, and then however much you go up or down on the y is going to be the gradient. So how can I go along 1 unit? Well, I can be clever here. I can divide this by 40 to get 1, and as long as I do the same to this one to keep it in proportion, I get 60 40ths. Now you could write negative 60 over 40 and that would be fine. You can cancel this down, however, to get minus 6 over 4, or even better, minus 3 over 2. Another way of looking at this is to again start from somewhere you know, say here, go along, read down, write the values in, so you've gone along 20, 40, 60 here, and you've gone down by, and you've got to be really careful, so this is 30 to 120, which is 90, and then you can just do the change in the y, if you'd call this the y-axis, divided by the change in the x. And so the gradient would be, it's still going downhill, you can see this very clearly as you move from left to right, and we would have the change in y, which is 90, over the change in x, which is 60, which is the same as minus 9/6, which again is minus 3 over 2. So it doesn't really matter how you do it, it would work the same if you did this division by 60 to make this unit 1 across here, the x-axis, and you'd do the same here. But just be very careful that you use your eyes and look at the steepness of that curve and see that it's going downhill, so you don't forget this negative sign here. Now let's have a look. There's a part B. It says explain what this gradient represents. Well, to me it represents that as time changes, the depth of water in the tank changes. So I would say that the gradient represents the rate of change of depth of water in the tank. So something of that nature would gain you the 1 mark. Question 11. It says Finley plays 2 tennis matches. The probability that he will win a match and the probability that he will lose a match are shown in the probability tree diagram. So we can see here a win 7/10 of the time, or 70%, or 0.7, and a loss 0.3. Don't forget these add up to 1 here. If he then won the first match, then the win for the second would be the same, and the lose for the second would be 0.3. Again, adding up to 1 each time. We're asked to work out the probability that Finley wins both matches. So we want a win followed by a win. Now, I have a video on why we multiply probabilities on probability trees, and I'll try and put a link on if I remember. If not, I can tell you now where I think it is. I think you go into a playlist called probability and you should see an explanation in there of why you multiply. Okay, so I'm going to assume you know that. So the probability that Finley wins both will be 0.7 times 0.7, which is, well, what do you think that would be without a calculator? Well, it'll be 0.49. Okay, so that's the first part done. Then it says, work out the probability that Finley loses at least 1 match. Now, personally, there's not much work to do, because to lose at least 1 match, what I would do is use the probability of winning both, and then every other combination involves 1 loss at least. Even 2 losses is at least 1 loss. So just go through that again. You can win, lose, that's at least 1 loss, and you can lose, win, that's at least 1 loss, and you can lose and lose, that's at least 1 loss. So really, isn't it just 1 take away the probability of 2 wins? And that's a very clever way of doing it, and on your calculator or in your head you can get 0.51 would be the probability of Finley losing at least 1 match. Question 12. Part A, it says find the reciprocal of 2.5. Well, if you write 2.5 as a fraction, when we want the reciprocal of something, we do it to the power minus 1, i.e. we flip it upside down if we have a fraction. So 5 halves to the power minus 1, or the reciprocal, is just going to be 2/5. And if you want it to be a decimal, then you can say 2/5 is the same as 4/10, which is 0.4. But if you wrote 2/5, that would be fine also. So let's do one more. Let's say we want the reciprocal of 0.3. Well, that's the same as 3/10. And then what we do is we just turn it upside down and we'd have 10/3. So 10/3 is the reciprocal of 0.3. And if you want to decimalize this, you'd have 3.3 recurring. So that's what the reciprocal means, and you can look that keyword up. It comes up quite a lot, just for like 1 mark. Part B is showing that you can use a calculator, I suspect. Now, let me write this out again here. Now, there's a few pitfalls for this question, I would say. And here they are. The first pitfall is make sure your calculator's in degrees, not radians or gradians, so you want it in degrees. Secondly, and I just missed out something here, there we go. And then secondly, make sure that when you put this into your calculator, if you're not really good at using the calculator, put in one part, then put in another part, find them separately, and then do the complicated bit at the very end. So if you know how to do this all in one go, then you don't really need to see any more explanation, you just need to see the answer at the end. But if you're not good with a calculator, here's a bit of advice I would give. Imagine you have brackets around this part, and this part, this part, and this part. So I'll just talk through what you can put in the calculator. So you put in bracket 4.3 times tan 39, and then close bracket. An alternative is open bracket 4.3 times tan, open bracket 39, close bracket, close bracket. That depends on whether your calculator automatically understands what the tan of 39 is as a separate function. Some calculators are different. Some calculators open a bracket here and expect you to close it here before you carry on. So once you've done this part here, and I'm just going to do that now and write that down. So I get 4.3 tan. Mine opens the bracket, you see, and then it expects me to close the bracket. And what I get for that is 3.4820713343. I'm writing everything down on my calculator display. Then I'm going to divide it by this number here, so I'm just going to put that in my calculator. You don't need a bracket here. You only need to put brackets in here if you're going to do this whole thing divided by this whole thing all in one go. Okay, but we're going to do it separately. So I'm going to do 23.4. I should be able to do that in my head, but it's late, and I'll use my calculator. And we've got 17.34. So I can do this separately now, okay, and I can put that into my calculator. So I'm going to do that. So I'm going to do 3.482071343 divided by 17.34, and that gives me 0.2008114961. And then what you've got here now is, it's like a square root sign with a little 3. Do you realise that means the cube root? And the cube root is like to the power 1/3. So again, that's full of pitfalls here. So what you do is, you've got your number in the calculator here, do your power button, and then either type in 0 point and then loads of 3's, at least 10, 12 of them, to get a good approximation to 1/3, or put in this number here and then do the to the power bracket 1 divided by 3, depending on your calculator. Some of them you don't need to do the bracket, but I would just do it just to be sure. So what you're effectively writing is the number here, 0.200 and so on, to the power, so you do your power button, bracket 1 divided by 3, and then the calculator will know that you're doing it all to the power 1/3. Some calculators can let you down, because if you put the number in and do to the power 1 divide 3 without the brackets, it will do it to the power 1 and then divide the entire answer by 3, which will give you the wrong answer. So my calculator, having done that correctly, gives me 0.5855934233. We want it to 3 significant figures, so we're going to have 0.586 to 3 SF. Question 13. Well, this is slightly new in the syllabus, to multiply 3 brackets out. It's quite common at A level though to do this on a regular basis. So as you've got an expression multiplied by an expression by an expression, doesn't matter which order you do it in. So I'm going to do these two first. So we've got 3x minus 1 times x plus 5. So we have 3x squared minus x, 15x minus 5. So I'll have 3x squared plus 14x minus 5. And all I've got to do is times it by the last bracket here. So I can just do another grid here. A quick way is just to do 3, 14 and minus 5. Forget the x squared, the x and the x to the power 0, because that's really like having x to the power 0 here, because x to the 0 is 1 as you know. Times by 4 and then minus 3. Quickly do these. So you've got 56 minus 20 minus 9 minus 42 and 15. And then the nice thing about this is you can say that your highest powers are going to be x cubed, so you've got 12x cubed. How many x squares will you have? Well, 56 minus 9, that is 47. Minus 62x, and then plus 15. If that scares you, then just put in these values and you'll end up having all these bits in here. So on, okay? But a faster way, you can just ditch the x squares, the x's and so on, and just go with the multiplication grid really quickly. So just to confirm, 12x cubed plus 47x squared minus 62x plus 15, and that's exactly what we need to show for all values of x. Question 14. ABC and ABD are two right-angled triangles. We're given some information here and we're asked to work out the length of CB, which is from here right the way through to there. Now, one thing that comes to mind is that there's two right-angled triangles and they seem to share a common length and some common angles. So let's have a look at whether we can draw them separate from each other. So I'm going to draw this one first, and that is triangle DAB with a right angle there, and then this is 5 and this is 13. Then I'm going to draw the larger one like so. Doesn't have to be really accurate, but I would do this in the exam. So C, B and A here. This is a right angle here. This length here is 13, and we've got angle B there is the same as this angle here, and therefore this angle here, I hope you understand that this angle here must be the same as this angle here, because if they already share two angles the same, then the final angle must be the same measurement, because they would add up to 180, and say if you had this one, the 90 plus the dot, whatever that is, well, it's the same as the 90 plus the dot here, so these two must be the same. So I think what we can say is that one of the triangles is an enlargement of the other, because if all the angles are the same, then if you enlarge one of them, and I would very much assume that it would be this triangle here, as it was the smallest one in the diagram. I know it's not to scale, but feasibly this triangle here has been enlarged to give this one. Why? Because if we look at the length between the 1 and the 2 dots here, then we can see that 13 has been multiplied by some scale factor, let's call it Q, to give this length here, CB, which is what we want to find. Because look, it's between the 1 and the 2 dots, okay, so it must correspond. So we can say with confidence that 13 times some scale factor of enlargement is CB. One thing we can definitely find out from this triangle is this length, because we can use Pythagoras. So we know that 13 squared is 169, you can use your calculator if you need to. 5 squared is 25, and so this length here, AD, must be 169 minus 25, which is 144, and the square root of that is 12. So we can just use Pythagoras to work that out. So we also know that 12 times the same scale factor of enlargement is this length here, AC. But the really nice thing, and I'll do this in a different colour here, is that 5 times the same scale factor of enlargement must be 13, because look, the right angle and the single dot angle, and here's the right angle and the single dot angle here. So this allows us to find the scale factor of enlargement. So Q must be, I'll divide both sides by 5 in this, and you'll get Q is 13/5. So we can find CB now, because CB is just 13 times Q, which is 13/5. So the answer is 169/5, which is the same as 338/10, which is nicely 33.8. You wouldn't have to worry if you put that as your answer, because that would be just as well, but I think some people are addicted to doing decimals here, so if you want to see the decimal, then there it is, 33.8, but this is absolutely fine also. Also looking at the question, if you couldn't spot similarity, I'm going to dare to try and do it another way, which seems logical in a way. Don't be too worried thinking you have to do everything the same way. But if you look at this triangle again, and you call this distance, say, x from there to there, then you know that this was 12 from before. So you could find this length here, which is x squared plus 12 squared square rooted. So let's just look at that for the moment, and then look at this large right angled triangle, and then use Pythagoras again. So you could say that using Pythagoras you've got 13 squared plus all this squared, which is just going to give you back the x squared plus 12 squared, and that would be equal to, don't forget, x plus 5, because that's the whole way across here, x plus 5 all squared. Now I don't know what's going to happen here, but let's have a look. So we've got 169 plus x squared plus 144 equals x squared plus 10x plus 25. So 169 and 144, let me just have a look at what that is. 9 and 4 is 13, that's 31, so that's 313 plus x squared equals x squared plus 10x plus 25. Then let's have a look. This would cancel, so we're left with 10x equals 313 minus 25, so 13 minus 5 is 8, 31 minus 3, so that's 288, and so x will be 28.8 because I divide both sides by 10, and so if x is 28.8, to get from here is x plus this 5 gives you CB. So CB would be 5 plus 28.8, which is 33.8. Maybe not advisable. I don't know how many people would try that, but like I said, they're the only two ways that I can see. Maybe you can use Socrator as well, but if you don't mind, I don't think I'm going to do that right now. So there's two ways for you, and you can choose which way is best for you, I think. Question 15. A pendulum of length L centimetres has time period t seconds. And it says, firstly, t is directly proportional to the square root of L. Now, having seen this question for the first time, I find this quite difficult actually. The length of the pendulum is increased by 40%. Well, if you started off with L, which was the length, and you want to increase it by 40%, then I don't know if you've seen one of my previous videos on the new SPEC, but I looked at compound interest, and there was one where something went up, I think 4% a year, and you times by 1.04. If you want something to increase by 40% all in one go, then you would just times that number by 1.4, and that would give you 1, which is where you started, plus 0.4 of the amount added all on together in one go. So I reckon that we would write something like t equals k root L for some value of k, and if L increases by 40%, then I would write k times the square root of 1.4 L, and that's the same as having k times the square root of 1.4 times the square root of L. Let's ignore this little bit here. Now, I think the square root of 1.4 is quite key here, so I'm going to put that in my calculator. And I get something of this nature. I get 1.183215 and so on L. Now to me, I think that tells me the answer, because if you started off with it increasing by 40%, this is L increasing by 40%, then L becomes 1.4 times what it started as. And when we square root this 1.4, we end up with 1.183215, which to me is having the original amount, i.e. 1, and then you've got 0.183215, which as a percentage is 18.3215 and so on. So I think my answer would be, to one decimal place, 18.3%, and I'll write 1 dp here. So just to recap, L increased by 40%, there you go, and no matter what k is, this relationship is still direct, because we have t is equal to some value of k, don't worry about that, it could be anything, times, well, this 1.4 is very significant, and the square root of 1.4 is 1.183215 and so on, which tells me that t will go up by 18.3% or thereabouts if the length increases by 40%. So sorry if I didn't explain that too well, but I've not really seen a question like this before, I have to say, so it's quite a challenging one, and I'm going to check the mark scheme to see if I was right. Looking at the mark scheme, it says answers between 18.3 to 18.4, so there we go, quite a difficult question. Question 16. The histogram gives information about house prices in a village in 2015. Now, one key thing to remember is that the area of each of these bars tells you the actual frequency involved, okay, i.e. how many. Now it tells you here that 20 houses have a price between 300 and 400,000. So we know that 20 houses is represented as an area here. So we can work out what this scale is. Now we've got to be really careful. So we know that 20 houses is represented here as an area. So 100 times what is 20? So 100 times something is 20. So on your calculator you can just do 20 divided by 100, which is 2/10, which is 0.2. My mind just went blank for a moment. Yeah, 0.2. So if this is 0.2, then don't forget here there's another one here, so that will be 0.1, 0.2, 0.3, 0.4 and so on. So it says work out the number of houses in the village with a price under 200,000. So we want all of these areas here, because the area basically represents the frequency. That's all you need to know about histograms. So for this one here, let's do this one first. It's going to be 50 multiplied by 0.4, 0.5, 0.6. So we've got 50 times 0.6, and I can leave that till later. Then this one is going to be 150 to 200, so that's 50. Forget that it's in the price in thousands, because the scale is going up in hundreds here. That's all you've got to think about. Forget what it means. It goes up in hundreds. That's the important thing. Whether it means 100,000 or not is not relevant. So we've got 50, a gap of 50, and a height of 0.7, 0.8. So we've got 50 times 0.8, which will tell us how many houses that area is worth here. And we want in the village with a price under 200,000. So of course some of you will be saying you wanted this one as well, and that represents, I should have done that one first probably, so that's 100 times. Now this scale is quite difficult, so we've got to be careful. If there's 10 gaps here and that was 0.2, then each gap is 0.02. So I don't think people are going to find that really easy. So what I suggest you do is, if you know that's 0.2 and there's 10 little spaces, just put in 0.2 on your calculator and divide it by 10, and you'll get 1/50 or 0.02. So we've got to look really carefully at how many gaps we're going up. Well, to here was 5, 6, 7 gaps, okay? Because that leaves 1, 2, 3 there to get to the whole one again. So we've got 7 lots of 0.02. So you can times 0.02 by the 7 and you'll get 0.14. So that's actually 0.14. And this is probably my least favourite question of the whole paper, to be honest. So we've got a 100 times here 0.14. So we've got 30 here. You can use your calculator if you want. Another 40, and then we've got 100 times 0.14, which is 14. So we've got 30, 70, 84 houses. So you probably guessed I'm not a massive fan of histograms, but I believe that to be the answer. Question 17. You're given the first 5 terms of a quadratic sequence, and you have to find an expression in terms of n for the nth term of this quadratic sequence. Well, I used to teach this many years ago, a good 15, 16 years ago, and then it seemed to go out of the GCSE syllabus and now it's come back in again. So at least I can remember how to do this. So I usually start with the natural numbers, 1, 2, 3, 4, 5 and so on. So I call those n, i.e. the 1 times table. Then I write out my sequence, I call that, say, s, and it's 1, 3, 7, 13 and 21. And all I have to do is find difference 1, and I call that the Greek letter delta. You can call it d if you want for difference. So difference 1, well, this goes up by 2, this goes up by 4, and then we've got 6 and then 8. So that's nice and predictable. It's the 2 times table. So we can see that our second difference is just 2 and then 2 and then 2. Now when we have a quadratic sequence, we'll always get a second difference which is the same, i.e. the same number keeps coming out each time. Now one thing I will do is, and for those that don't want to see this, then just skip ahead, it's absolutely fine. If you had a quadratic form, say s equals an squared plus bn plus c, then if I had my natural numbers, say 1, 2, 3, 4, 5 and so on, just like I had before, the 1 times table, and I wanted to work out the value of s when, say, n was 1, then I would do 1 squared, so I'd have a plus 1 lot of b plus c. If I put n is 2 in here, then this value would be 2 squared, which is 4, so that would be 4a. Then I'd have 2b plus c. And if I put 3 in here, then hopefully you'd see I'd have 9a plus 3b plus c. And I could put 4 in there and have 16a plus 4b plus c. And then I could put 5 in there and have 25a plus 5b plus c. Now if I look at the first difference here, and this is going somewhere, so bear with me, how different are these two bubbles here? So if I want to go from a plus b plus c to 4a plus 2b plus c, then I don't need any c's, I need 3 a's, and I need a b. What about the difference between these two? Well, I'll need 5a and a b again. Here, from these two, I'll need 7a plus a b, and then here I'll need 9a plus a b. And then I hope you can see here that the second time round the difference between these two is just 2a, 2a, 2a. Now if you've not been taught this by your teacher, then this is a good video to look at, because you can click on these questions one by one anyway, because I'll give links in the description bar. So if you want to just click on this question again and see this explanation, that's absolutely fine. And if you want to fast forward and get back to the other part of the question, then you just fast forward towards the end. Now the reason I've done this is because, look, we have 2a here, and in our question here we ended up with 2's. So I know that this 2 here is the same as 2a, so that enables me to find the value of a. Now don't forget, we know it's going to be a quadratic sequence and we want the nth term, so we know it's going to have the form an squared plus bn plus c. Okay, it's definitely going to have that form because it's quadratic. So we're lucky, we know that the a term is going to be 1, because 2a is the same as 2, which means a must be 1. So what I would like to do is, I always do this, I would put the square numbers down now, because I know that the square numbers go 1, 4, 9, 16, 25. And how many of these do I need? Well, a was 1, so I need one lot of the square numbers, so I just keep this row here and that's all I need. So is that the answer? Is the answer to this quadratic sequence n squared? Well, it isn't, is it? Because if I want to compare these now, my sequence was 1 and I seem to have 1 here, but then as soon as I start comparing others, I have a difference. So what is the difference between 1, i.e. the n squareds, the square numbers, and the first term of my sequence? Well, 0. There's no difference between them at all. What's the difference between 4 and what I needed here, which was 3? Well, I have to go back 1 to get there. What's the difference between 9 and 7? Well, I have to go back by 2. 16 and 13 back by 3, and then 25 and 21 back by 4. So all I really have to do now is, because I've worked out it's definitely one lot of n squared as the answer, so I can get rid of this here so I can do some more working. So we know it's definitely going to be n squared. I can draw a line under this, because all I have to look at now are these numbers here. Now, what do they go up or down in? Do they go up or down by the same number? Well, luckily for us, they do. They go down by 1 each time. And hopefully you know from when you've been taught that if a sequence goes up or down straight away by the same number, that means it's in a certain times table and it's linear. So if something goes down by ones, what times table does it go down in? Well, hopefully you can work this out and you can say it's the -1 times table. So if the 1 times table was at n, i.e. 1, 2, 3, 4, 5, then the -1 times table is -1, -2, -3, -4, -5. So, have we got everything we need? Well, don't forget, when we got to this line here, we'd already found out that we needed one lot of the square numbers, and we wrote that down. So we only had to look from this line onwards. We didn't have to start the whole problem again. So we tried looking at these numbers here. We worked out that they all went down by 1 each time, and we said we know what that is. It's the -1 times table, and here it is. So we definitely know that it's going to have minus the 1 times table, or just -n in the answer. But is that enough? Well, let's compare it to our sequence, and I'll choose a different colour. So let's have a look. How did -1 compare to 0? Well, we needed to add 1. How does -2 compare to -1? We need to add 1. Add 1, add 1, add 1. Notice I'm not comparing this number to where we started, because when I got to this line I'd already worked out that it had the square numbers in it, so I only had to look at this new sequence here and crack that one. So just to recap, we've got n squared, we've got -n, and now we've worked out that we just need to add 1 each time, which is the constant part. So our final answer is an expression, and an expression does not have an equal sign in it. Find an expression in terms of n for the nth term of this quadratic sequence. We would just write n squared minus n plus 1. So I apologise for the long explanation, but that's how I would approach many sequences, and I suggest that you try quite a few and see how you get on. Always try and get the quadratic part first, so that will be a multiple of n squared. Then get your linear part next, which will be a multiple of n, and then you'll always have to add or take something at the very end, and that will be your constant part. It's always the same process. Question 18. We're given a function of x as a quadratic here, 3x squared minus 2x minus 8. If you wanted to find f of 2, for example, that just means wherever you see x, it has to be given the value 2. So you'd end up with 3 lots of 2 squared minus 2 lots of 2 minus 8, and that would just give you 3 lots of 4 minus 4 minus 8, which would give you, well, 3 lots of 4 take away 1 lot of 4 is 2 lots of 4 minus 8, and 8 minus 8 is 0. So that's just an idea that x can take on any values you want. But in this case, it wants x to take on this value, x plus 2. So f of x plus 2 would be, well, let's write this out here. Now, this part here would normally be x if it was f of x, wouldn't it? Because that would be f of x, and then I've got a little square here, which I shouldn't forget. So back to here again, I'd have 3 lots of something squared minus 2 lots of the same thing minus 8. So if it was f of x, I'd have 3 lots of x squared minus 2 lots of x minus 8. Here though, wherever I see x, I've got to put x plus 2 in its place. So I can do that now. Then all I have to do is expand it all out and then see what we're left with. So we'll have 3 lots of, well, x plus 2 multiplied by x plus 2, well, that gives us x squared, and then we've got 4x and 4. So we've got x squared plus 4x plus 4, and then we can multiply this out, no problem. Just be careful with the signs. And then here we've got 3x squared plus 12x plus 12, and then we've got these values here. Well, straight away, hopefully you can see that these cancel out because we've got positive 12 and negative 12, and then we're left with 3x squared and then 10x. So it looks as though A is going to be 3 and B is going to be 10. Question 19. Here you have a right angled triangle and its perpendicular height is given as x minus 2 and its base is given as x. It says the area of the triangle is 2.5 centimetre squares. So, for those that are not really sure on the area of a triangle, a nice quick way in this situation is you should know what the area of that rectangle is. The area would be x times x minus 2, but we only want this part, so we divide it by 2. And it tells us this area is 2.5 centimetre squares. And if you're okay with this, I'd rather call it a fraction 5 over 2. So that's the first thing. Then you're asked to find the perimeter of the triangle. So the perimeter is starting from one point and then going all the way round. So a good idea to start with would be to look more closely at what I wrote here earlier. Now, if I double both sides, i.e. times both sides by 2, then I'll end up with x multiplied by x minus 2 equals 5. Then I could multiply this out, take 5 from both sides, and I'd end up with a quadratic in x. That should allow me to find the value of x, and once I've done that, I can find the perimeter because I can work out what x is, I can take 2 from x, and then I can use a little bit of Pythagoras to find the longest side. I can then add those 3 answers together, and that would give me my total perimeter. So let's have a look at this. There's a clue in the question it says correct to 3 significant figures. So I would doubt very much that this would factorise. So let's use the formula. So we'd have x equals minus b. So our value here would be 1, a is 1, b is minus 2, c is minus 5 in case you wondered. So x would be minus b, which will be minus minus 2, which is 2, plus or minus the square root of b squared, so negative 2 squared is 4, minus 4 times a times c, all over 2a. So that gives us 2 plus or minus the square root of 4. Now, be careful, we've got a minus times a minus at some point, so that's a plus. And then 4 times 1 times 5 is 20, all over 2. Now, of course, you've got a calculator, so before we look at that, I just want to do a little bit more with this and then show you how I'm going to use my calculator. Well, as is the calculator paper, I think it's a good idea to actually try and do as much as we can without. Of course, you won't do this in the exam, but I can try and show you a few other things at the same time. So from here, we'd have x is 2 plus or minus, well, 24 is 4 times 6, so it's the square root of 4 times the square root of 6, all divided by 2. So x will be 2 plus or minus 2 root 6, all divided by 2. So x would be 1 plus or minus root 6, because I've just halved the top and halved the bottom. Now, looking at the diagram, you know that x is one of the lengths. Now, if we did 1 take away root 6, that wouldn't be possible, would it? So we'd have to use x is 1 plus root 6. Now notice I've not used the calculator at all here. You could have used it much earlier here and you'd have been having some decimals. Notice I'm not going to use that just yet. Of course you can at any point. So if x is 1 plus root 6, then what do you think x minus 2 is? Well, x minus 2 would be 1 plus root 6 minus 2, which would be, well, 1 take away 2 is minus 1 plus root 6. So that's what x minus 2 would be. So in my triangle, I've got this length now. So I've got x, which is 1 plus root 6, which of course we'll decimalize in a minute. I've got this length here, which is minus 1 plus root 6, and I can decimalize that too. And then we can use Pythagoras to find this one because it's a right-angled triangle. Now, for those that don't want to watch anymore, that's absolutely fine. You don't have to. You can just skip to the end and use Pythagoras on your calculator and see if you got the same answer. For those that want to look at this without a calculator, well, let's have a look. So we'll square this one here. We'll square this one here. And then we'll add them together, because don't forget, with Pythagoras' theorem, we've got this area plus this area gives the larger one. So I'm just going to get rid of this, and we'll go from here. So if I square this bracket out, now if you had 1 root 6 and then 1 and a root 6 and you multiplied them out, you'd have 1 root 6, another root 6, and then root 6 times root 6 is just 6. So you'd have 7 plus 2 root 6. This one here, I'm just going to write it down here, and I'm going to call it root 6 minus 1, because that's exactly the same as minus 1 plus root 6. It's just easier to write. So here is 6, I've got minus root 6, minus root 6, and then minus 1 times minus 1 is just 1. So here I've got 7 minus 2 root 6. So the interesting thing here is, and I've never done this question before, you've got 7 and 7 is 14, and these two cancel. So the area of that big square is 14. So to find this length here, I just have to square root it. So I get the square root of 14. So I've not used a calculator yet, and so the perimeter would be this length here plus this length here as x plus this length here as root 6 minus 1. So what do we have altogether? Well, we have root 14, and then we have plus 1 and then minus 1, which is 0. I didn't really need this bracket, but I just wanted to put it in a bracket so you could see where the root 6 minus 1 came from. And then I've got root 6 and another root 6 is 2 root 6. Now I can put that in my calculator and see what we get. So I've got the square root of 14 plus 2 root 6. And I get the answer as 8.640636 and so on. So we want it to 3 significant figures, so we're just going to write 8.64 centimetres to 3 significant figures. Now, just one final thing to say with this question. The reason I've done it in this particular way is not to annoy people who are looking at how to do this question. My journey through maths has not always been an easy one, but I found that if I look at a question and try and do it in as many different ways as I can, if there's a calculator question, then I'll try not to use a calculator, and vice versa. So I think if you can do your non-calculator methods really well, you end up learning about things like surds a lot more quickly. You end up doing your multiplication really well, and then you appreciate when a decimal is a good thing to write and when it isn't. Personally, I think that this is a very nice value to have as your perimeter because it's exactly correct, whereas this is just an approximation. So take from a question what you can, especially when you do revision. But of course, when you're in the exam, you're going to have to get your skills really sharp and then go for the very quickest, most efficient way that you can get the marks. Question 20. Probably the most difficult question to explain that I've come across. This used to be on the specification before the last specification, so this is probably back in 1997, 1998 when I first came into teaching. This used to be on the syllabus, and then it was taken off in 1999, I think, or 2000. Now, it's back on again, so you need to kind of think carefully about A, how you interpret the question, and B, how you go ahead and do it, because you want to find out an estimate for the acceleration. Now, if you're okay with acceleration being the rate of change of velocity with respect to time, then that would be good. If you're not, look at the units of acceleration, and it's meters per second squared. Well, that's the same as meters over seconds times seconds, because that's how you get seconds squared, which is the same as meters per second divided by seconds. And then if you think carefully, what is meters per second, i.e. distance over time? Well, that's velocity, and seconds, that's time. So you've got v over t. So you've got a change in velocity over a change in time. That's one way of looking at it, and that's looking at the dimensions of what you've got. And there's always clues here, like there's the dimensions there, meters, here's the dimensions here, meters per second squared. And look, there's another one here, velocity, meters per second. So one way of doing this is to look carefully, and I'll zoom in on the graph here, is to look really carefully at the time that you want it at. So here we go. 6 seconds. And all you have to do is try and draw an accurate tangent at that point. So let's have a look at that first. And I'm going to try and not mess this up. So I'll do it in red. Okay, blue then. And we'll try and draw a tangent. So you can see that's not a good one because it doesn't go through that point, t equals 6. That's quite a good one. And I'm sure in the exam they'd give you some leeway, so I'm probably going to leave it around there. Okay? Now, that would give you, if you looked at the gradient of that tangent there, that would give you a really good approximation to the rate of change of velocity with respect to time at that particular point, t is 6. And we know, I think it might have been question 10 when we had water in a tank. I don't know if you remember that one. If you don't, go back to question 10 and have a look at that. Rate of change was mentioned then. I think if we just try and estimate, and now it's a good point from there, so if we look along some units here, let's use it up to that point there. In fact, doing this question reminds me of when I was like 15 and 16 when I had this on my syllabus. We had to do exactly the same. So this is 2, 4, 6 here, and we're going up by 10, 20, now let's have a think, 10, 25. So I would say that the gradient of that line would be, now you can do it two ways because I think I explained that in question 10. You can either divide this by 6 and then this by 6 to scale it down to going along one unit, and then you're going, think about it, uphill, so it's a positive gradient of 25/6, and I'll use my calculator for this. 25 divided by 6 gives me, let's get this right, gives me 4.16 recurring, so I would say around 4.2 to 1 decimal place meters per second squared. Now, if you don't like that, then go back to how you found this at 6 and how you found this at 25, and then try and justify to yourself, this axis here was the velocity that was given, and this axis here was time. So if you do 25 divided by 6, that should make sense because you've done v divided by t. And try and think back to what we said. Does that make sense as acceleration? Well, v over t, v is meters per second, distance over time, t is seconds, and that's the same as meters per second, i.e. meters per second squared, which is acceleration. So yes, doing this value divided by this one was a very good move. So that would be my answer to the first part. The next part of this question is probably even more difficult to explain. It says, work out an estimate for the distance fallen by the parachutist in the first 12 seconds after leaving the plane. Well, I'll try and explain this as best I can because I do understand that some of you may have some difficulties, and you might have supply teachers or cover teachers, for example, so I'll try my best to explain it for you. If you want to estimate the distance fallen, the distance, then look at this. Speed equals distance over time, and in this case we've got velocity, the distance, and the time. So here's the time, here's the velocity, and in very simple terms, if you want to find the distance, you've got to somehow do velocity times time. I hope you can see that from here, that if I rearrange this formula, i.e. times both sides by t, I'll have vt equals d. Now, if you think of, say, this square here, then what's its area? Well, it seems to be a t measurement going this way multiplied by a v measurement going this way. So that would represent some distance. So really what we're trying to do is we're trying to find the area underneath that curve from 0 to 12 because it wants the first 12 seconds. And it says use 3 strips of equal width. So let's have a look and see what that could mean. I feel reasonably confident at this because this is at A level, you see. You have to use the trapezium rule. Don't worry about what that sounds like, but you do this kind of method quite a lot. It's like a way of estimating areas. Okay, so if we want 3 strips, we've got from 0 to 12. So if you divide 12 by 3, you get 4. So if we do an estimate there, so we'll put a line here at 4, the next one, 4 more, 8. Now, let's have a look at what we can do next. Well, my much preferred way is to make it into trapezia if you can. Okay, so trapezia is how we spell this, and it's the plural of trapezium. So I can see a trapezium here, and I can see one here, because if I just draw this here, that's like the end point. I can also see one here, and you might say, well, hold on, this is a triangle. Well, yes, it is. Okay, and that's fine, but if you want to look at it as a trapezium, which doesn't have any height here, that's good also. So how could we estimate the area from that? Now this has got the old question underneath, so we won't show too much of that. Well, let's have a look. Let's find the area of the middle one, because you should know how to find the area of trapezium. You need a common height here, and the heights here, because we had 3 strips, we split them into 4s, so the common height for each of these is 4. So that's good. And the area of a trapezium is the common height divided by 2, lots of the 2 heights of the parallel sides. So these are the parallel sides here. Imagine there's one here, but it has no length. Okay? So this length here, let's just look at this middle one here. So we call this T1, and then we can do the others quite simply. So let's look at this height here. Well, the height clearly seems to be from the graph 35. And the height of this one here seems to be 50. So we can put that in here. So that's 35 plus 50. Now, what we can say is we also know what this height is, and it's 4. So we can say it's 4 over 2 lots of 35 plus 50. Now, we'll call that area of T1. How would we find the area of T2? Well, let's have a look at that. I've made a little bit more room for us. So this length here is about 54, I would say. Let's just get my readings correct. Yeah, I'd say that's 54. So the area of trapezium 2 would be the common height of it, which is 4, divided by 2, lots of 50 plus 54. And then let's look at the area of trapezium 1. Sorry, trapezium 3 we'll have to call it here, because I've called this one number 1. Well, that's 4. Try and resist calling it a triangle for now, base times height divided by 2. Just trust me and do a trapezium. So you've got 4 divided by 2, lots of 0, that's nice and easy, plus 35. Now, I want you to try and notice something here, because if you can get this technique right, then this will be really good. Let's list these in some kind of order. So let's do this one first, because that's what we should have really done. So we'll have 4 over 2 lots of 0 plus 35. And then let's add it to the next one, which we call T1 here, which is 4 over 2 lots of 35 plus 50. And then finally let's add it to this one in order, and there it is, and that's 4 over 2 lots of 50 plus 54. Well, here's a really nice thing to see now. Hopefully you can all see that this would give me an approximation for the area if I added all those together. Well, can you see that 4 over 2 is a common factor? I'm not going to call that 2 yet, I'm just going to call it 4 over 2. Now, let's look at all these numbers in the brackets. How many times do they appear? The 0 appears once. The 35 appears twice. The 50 appears twice, hence timesing it by 2 outside the bracket. And the 54, well, let's close that bracket because it only appears once. Now, for some of you, you may have spotted a really nice formula, and that is the area, as a rough estimate, would be the common height divided by 2, lots of, well, we can call this the y-axis, so we can call this value here y1 plus 2 lots of this value here. Why? Because can you see this 35 is shared in the first trapezium and also in the second one? It's like back to back, so it's shared, so we'll call that y2, our second y value, plus 2 of these, because the 50 is shared twice here. It's 50 for this one and also 50 for this one, and we'll call that y3, plus the very last one, y4. Now, some of you may be lost at this point, some of you may not be. Some of you might understand that we always look at one of these, 2 of these, 2 of these, and 1 of the end one. So no matter how many trapezia you draw, it's always 1 of the first length, 1 of the last length, and twice of all the middle ones, and you always times your answer by h over 2, and h is always the same thing. If it's the same for one, it's the same for all. So depending on how you've understood this, you can either do it in 3 stages and say, put this in calculator, put this in calculator, this in calculator, and do them separately. I think we're good enough to go from here. And then we can say, in the bracket we're going to have 0, 0 plus 2 lots of 85 plus 54, which is going to give us 2 lots of 170 plus 54. 170 plus 54 is 224, times the 2 is, well, 448. Now, reviewing this question, I can see one little error that I made, and that is here. It's a bit silly of me, but I can just see it now. This wasn't 50, was it? It was 51, so I just have to go back here. God, what a mess this is. Let's have a look. Go back here, and I can change this to 1 here, so that would be 86. So 2 86s is 172, and then that would be 6, 2, that would be 452, and half of that is 226, and that's what that would be. Okay, so I get 452. Now looking at the question with a fresh pair of eyes, having spent a minute away from it, I would say for GCSE that if you did estimate this as a triangle here, i.e. 4 times 35, which is 140, and then halve it and have 70, and then add the two trapezium together separately, or the two trapezia I should say separately, that would give you the answer as well. So I do apologise for the complete mess for this question, but it's very hard to explain. So in short, and I'll use one more colour here, triangle, trapezium, trapezium is fine, or you can treat this triangle like a trapezium. Prepare yourself for the A-level and use the trapezium rule, which I shall just write down here. That comes up at C2 quite a lot. Whether C2 will be the same if you ever come to do it, because they're doing the changes to the A-level in 2017, but I'm pretty much sure that the trapezium rule as a way of estimating areas under curves will be something, if you carry on with your maths, that you'll be looking at again. So it's probably a good idea to try and grasp the ideas now. But again, apologies for the mess, but I'm not going to do this question again. In fact, I can't wait to see the back of it. Question 21. The number of bees in a beehive at the start of year n is P subscript n. The number of bees in a beehive at the start of the following year is given by this following formula. So I'll write this out again. Now, what we have here is something called a recursive formula or an iterative formula. What it means is that if we start with, say, n being 1, that's P subscript 1. And in this case, that would be at the start of 2015, and there'd be 9,500 bees. What that would then enable you to find is how many bees there'd be in year 2. So let's just try n is 1 and see what we'd have here. Well, if n is 1, we'd have 1 plus 1 is 2, so we'd have P subscript 2 would be 1.05 lots of, well, we know that P1 is the first year, and at the start of 2015 there was 9,500 bees, so we know to put that in there. Now we're going to use our calculator. I'm not going to do this by hand. And I get 9,712.5. Now, I don't know if you would think of that as 9,712.5 bees, but we know there wouldn't be half a bee necessarily. So we'll keep it as what it is, and we'll just try and find what there'd be for the next one. So P3 subscript 3, what do you think that would mean? Well, if P subscript 1 was the start of the first year, then P subscript 2 would be the start of the second year, in this case 2016, because this one was 2015. So we've got 9712.5. So P of 3, well, that will be 1.05 lots of the previous year's worth. And we take away 250 as normal. So let's put that into our calculator and see what we get. In this case, I get 9935.625. So that would be at the start of 2017. So I'll put that in here. And then at the start of 2018, which is what we want, I'm going to put that number back in again. So we'd have 1.05 lots of 9935.625 minus 250. I'll put that in my calculator. And I would get 1 90169, so 10,169.90625. So to the nearest B, which seems pretty strange, but to the nearest B, that would be 10,170 B's. So just be very careful when you're using iterative formulae. These parts always stay the same, and it's just these parts here that will change successively. So you're always given a starting figure, and then you just input that starting figure, get the new figure, and then put that old figure in here, and then create another one, and so on. I wouldn't advise rounding any of these figures here and then putting them in. Just leave them as they are, and at the very end then you can round to the nearest whole number depending on the context of the question. And we were talking about B's, so it's either 1B or it isn't. Okay, you wouldn't have 0.90625 B's. So that's iteration. I haven't done an iteration question yet, so that must be something new on the new specification, but it does come up a lot at A2, so if you're wanting to do A-level maths, then you're bound to see these types of question quite a lot. Question 22. We're given that d equals x divided by y, and we're also given that x is 99.7, correct to one decimal place, and y is 67, correct to two significant figures. And we've got to work out an upper bound for d. Well, first of all, let's take x, and if you've watched any of my previous videos when I've looked at upper and lower bounds, I go about it in exactly the same way each time. So if we take x as 99.7 to one decimal place, then if we take the place value at that place here, then our place value is 0.1, i.e. we're talking about tenths. And all we have to do here to find the upper and lower is split the 0.1 in half, and we'll get 0.05 each way. So if we want the upper bound here of 99.7, we would add 0.05 to it, and we'd get 99.75, and that would be the upper bound. And then to get the lower bound, we just take 0.05, and that would give us 99.65, and that would be the lower bound. With the number 67, as it's given to two significant figures, then we take this second significant figure here and we say, what does that 7 represent? Well, it represents units. So just like before, we split the unit in half and we get 0.5 each way. So if we want the upper bound of 67, we would add 0.5 to it, and that would be 67.5. And if we want the lower bound of 67, then we take 0.5 away from it, and that would be 66.5. So that leaves us with the question now, what's the upper bound for d? Well, we know that d equals x divided by y, and it says we want the upper bound for d, i.e. we want d to be its most. Now I like thinking of this as cakes and people. Basically, you want to end up with the most cake. So to end up with the most cake, you need this number to be its upper bound, i.e. the most cake, and selfishly you'd like the least amount of people to turn up, because then if you had the most cake on the table, the least amount of people showing up, you'd end up with more cake if it was shared out equally. So d, the upper bound, will be the x value being its greatest, so that's 99.75, and the y value being its least, and that is 66.5. You then use your calculator, and let's see what I get. So 99.75 divided by 66.5, and I get a value of, rather strangely, it works out as the upper bound is 1.5. Question 23. Here is a circle, centre 0, and the tangent to the circle at the point 4, 3 on the circle. It says find an equation of the tangent at the point P. Well, I wouldn't worry too much about these. Know your circle theorems quite well, because one thing you should know, and this crops up a lot at A level when you're using this, and these kind of questions appear in C2, which is Core 2 at AS. So my advice to you is know that the angle between a radius and a tangent is 90 degrees. So what we can do is be a bit sneaky here. We can say we can work out the gradient of this radius here, and then we know that the gradient of the line must be normal to it. And I think if you know something about gradients when you've got two lines that are normal to each other, you take one of these, you turn the gradient upside down, i.e. find the inverse and the reciprocal, and then change the sign. So you know that this gradient is uphill, so you know the gradient of this one will be downhill. So let's have a look if we can find the gradient of the orange radius. Well, this coordinate here is 0, 0, and we'll call this capital O. So the gradient will be the change in y over the change in x. So I'm going to do this value of y, so I'll change the colour of the pen. So I've got 3 minus 0 divided by 4 minus 0. Please note that you could have also done 0 take away 3, which I'll write down here, divided by 0 take away 4. It doesn't matter which way you go, as long as you do the same way each time. So what do we get here? Well, we get 3/4 here, and we knew it was uphill anyway. Look, use your eyes and use your common sense. This is going uphill, so its gradient's going to be positive. And this one you're going to have -3 divided by -4, which is also going to be 3/4, because a negative divided by a negative is a positive. So we know that m is going to be 3/4. So we know then that the gradient of this line here, and we're just going to call it L. So we know the gradient of L is going to be, well, it's definitely minus because the other one was positive, and all we do is we just turn the 3/4 upside down and we get -4/3. I hope your teachers explained that if you have the gradient of one line and then one that's perpendicular to it, if you multiply the gradients together, you always get -1. So we can test that. We had 3/4 times by -4/3, and yes, 4 divided by 4 is 1, 3 divided by 3 is 1, so we're left with -1. So enough of that. We've got the gradient here of the line we wanted. So the gradient is -4/3, but we also know it goes through this point. So you've got two choices here. You can either use the formula y equals mx plus c, plug in the gradient, and then plug in the values x is 4 and y is 3. So we can do that first. So we'll have y is 3, our gradient is -4/3, our x value is 4, and that leaves us our intercept, which we can then find from that. So I'm going to times everything by 3 here. Add 16 to both sides, and divide by 3. And then I can just write this out now with the values of m and c, which I now know. So for any values of y and x, we're going to have y equals minus 4/3 x plus 25/3. That's one way. Another way, and as this is the new specification, you can look at this other way. If you don't want to see it, then just go to the next question. If I have y and x here, and I have a point here, say xy, and another point here, say x1, y1, then if I join these up and make a line segment, I can find the gradient of that line segment by just making a right-angled triangle. And I can look at this value here, which is the difference in y. So this is going to be y minus y1, and this distance here is going to be x minus x1. Because if this was x and this was x1, then this distance here is just going to be the difference between them. And you should know that the gradient, therefore, is the change in y divided by the change in x. If you don't like that, a nice way of looking at the gradient is to say, well, if I go along 1, how far do I go up? And it's how far you go up is the gradient. So I can go along by 1, and I can be very clever here, very sneaky, and just divide both sides by x minus x1. Do the same to this to keep the triangle in proportion. And then this ends up to be 1, i.e. 1 unit along. And then look what I've got up. This will be the gradient. So I'll have m is y minus y1 over x minus x1. And if you multiply both sides by x minus x1, you end up with a lovely formula here, which I use all the time. And I always write it in this way, the y's first. So I'll do y minus y1 is m x minus x1. Now you might say to yourself, well, why is this formula nice? Well, all you need to do with this formula is to know which point the line goes through, and we knew from the question here, which you probably can't see, but P was 4, 3. So we know that our x value here is going to be 4 and our y value is 3, but we want to find a formula for any x and any y. So our x1 value is going to be 4 and our y1 value is going to be 3, because that will leave us with a y and an x, i.e. any x and any y. And look, we know this value of m also. So let's use this way, and this is more of an A-level way here, more of an A-level way of doing things. So putting in the values, we'll have y minus 3 is the gradient minus 4/3, lots of x minus the x1 value, which is 4. Don't forget we chose x1 and y1 to be 4 and 3 because we wanted it for any y and any x. So you need to leave y and x in the formula. Well, it's up to you how you want to finish this part of the question off. I think what we can do here is we can times everything by 3 to get rid of this denominator here. So we can have 3y minus 9 equals minus 4x plus 16 by just multiplying this part out. Then I can add 9 to both sides. And then what would I have? Plus 25. And then I can divide everything by 3. So exactly the same as what I'd have using y equals mx plus c. So I have to say, if you wanted to go on and do A-level, I would probably end up using y equals mx plus c a lot less, and you'd end up using y minus y1 is m lots of x minus x1 a lot more. But try and understand this here. I think I have another video on it in the playlist called Straight Lines, So if you want to look at that all over again, then do so. Question 24. You're given A, B and C are points on the circumference of a circle, centre 0. Prove that angle BOC here is twice the angle BAC. Well, I'm really glad that this kind of question is on the GCSE because I've always tried to teach the circle theorems using algebra, and I'm going to do that now. So what I'd like you to think about is that radii are really important here. So if I draw a radius from O to A, and I just extend it a little through here, okay? So I've just done a little part of a line. It doesn't look very straight, but it will do for now. So we know that this is a radius here, OB, we know that OC is a radius, and we also know that OA is a radius. So just this bit here. Now, the fact that they're radii is really important here. So let's have a look why. All we have to do with this question is choose one angle in this diagram to be x. It doesn't really matter which one. So let's just go for, say, this one. Then we know that this must be x as well, because the triangle OAB is isosceles. Why? And it's back to what I said, radii hold the key here. They're the same, and that's why. So what must this angle be? Well, all the angles in a triangle add up to 180, and we already have x and another x is 2x. So surely this must be 180 minus 2x, because only 180 minus 2x, add x gives 180. We know that angles on a straight line are 180, so this angle here has to be 2x. Why? Because if we take 180 minus 2x and add 2x to it, we get angle on a straight line, which is 180. Now, all we've got to do in the other diagram is choose another letter, and we can call this y here. So this is y for the same reason as before, isosceles. So this angle here is 180 minus 2y. So this one is just going to be 2y for the same reason as before. Angles on a straight line are 180. So what do we get for the angle B to O to C? Well, BOC seems to be 2x plus 2y. But what about angle BAC? Well, we've just got x plus y. So I hope you can now see that BOC is actually twice BAC. And if you like your factorising, then this is a little stronger. Hopefully you can see here that this is twice x plus y, and this was just x plus y. So BOC is indeed twice as much as BAC. So that's the way I would do this. If you want to see another way of doing it, then carry on watching. If you don't, then go forward and you don't have to watch this. So I'm going to choose another letter here, and I'm going to put A, say, here. Then this angle here, well, what would that be? Angle on a straight line is 180, so this would be 180 minus A. This is a little bit more complicated, but you should be able to work it out. Hopefully you can see with a bit of thought that these must be A over 2 each. Why? Because A over 2 plus A over 2 is just A, and if you add that to 180 minus A, you get 180. And then likewise, I'm going to call this angle here, say, Q. This will be 180 minus Q, and then these will be Q over 2 and Q over 2. So what do we get for BOC this time? So this time, BOC is just A plus Q. But what about angle BAC? Well, that's just A over 2 plus q over 2. And if you like your factorising, you can take half out as a factor. And what do you notice? Well, hopefully you notice that BOC, which is a plus q, is twice as much as BAC, which is a half a plus q. So there you go, there's two ways, and there's probably others as well. Just be inventive with your expressions and your algebra, and all of the circle theorems, every single one of them unfolds really quickly. Don't forget, when you come to write your answers in the exam, you'd need to write things like isosceles triangles, angles in a triangle out to 180, and so on. So you'll need all your explanations written here. Not in massively long sentences, but you'll just need to write a bit more structure to it. So I've given you a brief overview of how to prove this. When you come to write it out in the exam, you'd have to put a little bit more content in there.